On ray diagrams for a converging lens. I'm going to talk you briefly through how we construct a ray diagram and kind of what it means, because often that is lost on students. And we'll look at a few examples of this and how it works. Okay, so we'll start with the image that you can see on the right hand side. Here we've got an object, and the light from this object is going to pass through the converging lens. Now, sometimes when we draw these diagrams, the converging lens is a little bit big. All right, it's maybe not quite realistic, but the physics of it is realistic. It does work very well, and we'll see how this works. You'll notice here that my object is fairly far away from the lens. Okay, we've got our points marked on there, F, where F is the principal focus, and actually this is our object is greater than a distance 2f away. In other words, it is more than 2 focal lengths away from the lens itself. The way that we construct our lens diagram is as follows, and you can see on the screen with the blue lines. First thing we do is very simply draw 3 rays. Now this is, some people will differ in their opinion on this. Some will be happy with 2. I like my students to draw 3 just to confirm what's going on in the lens. One of them passes horizontally from the object, from the top of the object through to the middle of the lens. And you can see we've just got a nice horizontal line extending from the top of the object to the midline there of the lens. Notice it's not necessarily going to the top of the lens, because that depends on the size of the lens. It's just simply traveling nice and horizontally. One of them passes directly through to the center of the lens, and the other one passes through the nearest principal focus, F. So you'll notice that we've got 3 lines. I've stopped drawing them all at that center point of the lens, because at that point refraction is going to happen, and that's where we're going to see the effect of refraction on each of these rays. Now actually, if you've been sort of following on with this, you may be aware that really all we have to do here is do some inversion. Okay, you'll notice here this is what happens to the rays after they've traveled through. That top ray becomes refracted, and it refracts through the principal focus on the right hand side of the lens. The second ray doesn't do anything. The center ray just doesn't change its direction, it simply carries on. And the third ray bends so that it becomes parallel with the axis. In other words, it becomes horizontal. So you'll notice here that my rays converge at a point, and this is where the image forms, and that's really important. We've got our lines meeting. We've said before that a real image is one formed where light rays meet each other, and that's really important when we're using a lens, because we're using the lens to form images, and in this case it is a real image because those lines, those rays, have met each other. You can see also, if we compare the object and the image, that the object is upright and the image is upside down, it's inverted. And so this is a particular feature of this type of image, that we are producing a real inverted image. The image is forming where those 3 lines cross each other. And in this case, as we said, it's upside down. It's real because those light rays are meeting one another, and it is also diminished. In other words, it is smaller than the object. Now this is where I think it's really good to think about our real life application. One application of this would be in our eyes, because in our eyes we have got a converging lens. You should be aware, however, that if I look at, say, a tall object, a tree, a building, that it doesn't necessarily look that big if it's very far away. Well, that's what you can see in the diagram here, that tall objects, big objects, become diminished. In other words, their image appears smaller than the reality. Now, that's really important for us, because if this wasn't the case, then we would see large buildings as bigger, for example, or we might see small things as smaller. Well, in this case, actually, we see bigger objects as smaller because they're further away, and that's all to do with this ray diagram that we're creating. Now, obviously, what happens to the image depends greatly on the distance of the object from the lens, and that's what we're going to be investigating in future exercises. Thank you for watching.